Hi, George Diamond here today. Now today we want to take a look at evaluating a definite integral using U-substitution. Now in my textbook this is section 4.4, we use the Larson text. Now if you're watching this video, I'm assuming that you already know how to find the antiderivative using U-substitution. Now if you don't know how to do that, you may want to go back and watch video number 1. Right, but I'm assuming that you already know how to find the antiderivative using U-substitution, that is, how to do indefinite integration using U-substitution. Now, today we're going to look at evaluating a definite integral. So that would include area under a curve, etc. So those types of problems. Now we just do a few examples, but when you using U-substitution with definite integration, we follow pretty much the same process, but we have to convert our integral from an integral in terms of x to an integral in terms of u. Now, one thing you got to watch out for is your upper and lower bounds. So we're going to have to not only everything has to be converted from an integral in terms of x or t or whatever the original variable is to an integral in terms of u. Okay, so that includes your integrand. Okay, that includes the dx and the upper and lower bounds. So those need to be converted to in terms of u also. So, without any pause, let's go ahead and get started with our first example. All right, so we're into about 4 examples. We'll try to do a trig example, a radical or 2, so we'll do a couple of those. So let's start off with our first example. Let me see if I can erase this here. And we'll try our first problem. All right, so let's see if we can evaluate this definite integral here. So problem number 1. Okay, let's try this definite integral here. So the integral from 0 to 3, x times x squared plus 1. So x squared plus 1. Okay, dx, and this is x squared plus 1 to the 3rd power. All right. Now let me double check this, make sure I've got this problem copied down correctly, all right? So we don't want to. All right, I think we're good to go. All right, so x squared plus 1 raised to the 3rd power. So make sure you got the problem copied down. So some of these can be kind of long problems, so you got to make sure you got everything copied down correctly. Now, to begin with, with U-substitution, let's start off by letting what's inside our parentheses here be u. So we'll start off by letting u equal x squared plus 1. All right, now, to convert our integral from one in terms of x to one in terms of u, and so you got to take the derivative of this expression now. So the derivative of u is du. So on the left-hand side will be du. So the derivative of u in terms of u will be du. Now on the right-hand side, the derivative of x squared is 2x. The derivative of 1 is 0. So on the right, this will be 2x times dx. Right. Now to get ready for our substitution, now let's solve this little expression for dx. We're going to divide this side by 2x. We're going to divide this side here by 2x. We have 1 over 2x du equals dx. Okay. All right, now we're ready now to convert the integrand from an integrand in terms of x to one in terms of u. But there's still one more thing we got to do. So we're going to have to change the upper and lower bounds. When you see 0 and 3, now remember this is x equals 0 and x equals 3. So we need to convert those now to upper and lower bounds in terms of u also. Now to do that, we're going to use the original statement up here, so the original substitution statement, u equals x squared plus 1. So that means that u of 3 is equal to, substitute 3 in for x will give us 3 squared plus 1, okay, which is 10. So that's going to be the new upper bound. Let's substitute 0 in for x also. So u of 0 would be 0 squared plus 1, which is 1. All right, so whenever we convert the definite integral from one in terms of x to one in terms of u, okay, now our new integral becomes, so instead of 0 to 3, this will be from 1 to 10. So the lower bound now is 1 and the upper bound now is 10. So this is u equals 1 to u equals 10. So we've converted the upper and lower bound from upper and lower bounds from in terms of x to in terms of u. Now within the integral now, this is x times Now, x squared plus 1 is equal to u, so that's going to be u to the third power times, so times, let's see, we did erase this here, so times, let's see, now dx is 1 over 2x du, so 1 over 2x du. Okay, I think I can get by with that right there. Okay. Now, if we do this correctly, then we should be able to cancel out any extra x's. So this x here is going to cancel out with this x in the, with a substitution there for dx. So the 1 over 2x will cancel out, the x's are going to cancel. Now also we have an extra factor of 1/2. So this is now 1/2 du. And we want to pull that 1/2 out in front of the integral. That's supposed to be 1/2 integral from 1 to 10. Now the x is gone. We pull the 1/2 out front, and that gives the integral u to the third power du. Right, now remember, when you use U-substitution, you start off with what looks like a really complicated, difficult integral to one that's actually fairly simple to integrate now. So, so now we're ready with this integral. Now we've got everything in terms of u. Okay, let's go ahead and find our antiderivative now. So the antiderivative will bring the 1/2 over. The antiderivative of u to the third power, remember, you're going to add 1 to your exponent, divided by the exponent plus 1. So it'll be u to the 4th over 4 from 1 to 10. Now, so go ahead and find your antiderivative. So remember, with when you do integration, you're going to add 1 to your exponent, divided by 3 plus 1. So divided by the exponent plus 1. Okay, this will give us our antiderivative here. Now, to evaluate our definite integral, just a matter now of substituting 10 in for u and then 1 in for u and subtract. So you will substitute your upper bound minus your lower bound and then go ahead and evaluate the definite integral. So now first of all, 1/2 times 1/4, so this is 1 over 4, is going to give us 1/8. So 1/8 times 10 to the 4th power, okay, minus 1/8 times 1 to the 4th power. All right, so substitute your upper bound into your function for u. Substitute 1 in to your function, your lower bound into your function for u. So the upper bound minus the lower bound. And let's see what we get now. Let's see, 10 to the 4th power is 10,000. So it'll be 10,000 over 8. That'll reduce to, let's see, so 10,000 over 8. Well, I don't need to reduce it right now, so we'll leave it like it is. That'll be 10,000. This will be 10,000 over 8 minus 1 over 8, which would be 9,999 over 8. So that will be our definite integral. Now, as a decimal, I believe this is 1,249.875. Right, so that would be our answer in decimal form, right? Okay, so this is our integration. Just have to remember, you're going to substitute, you're going to convert every part of your integral from an integral in terms of x to an integral in terms of u. So in this case, it's kind of the chain rule in reverse there as we evaluate this definite integral. And you got to, after you start your substitution, let u equal the quantity inside your parentheses in this case, so x squared plus 1. Take the derivative of both sides, so and substitute for solve for dx, and then you're ready to convert the integrand. Then you have to convert the upper and lower bound also by substituting in for x, and then I will set up our integral in terms of just in terms of u. Okay, let's try a trig example now. So there's a pretty good one to start with. So let's try some trig example. Erase this. And so we're going to we'll try a radical example or two. So we'll try several problems here. Let's see if I can erase this. Okay. And let's see, example number 2. Now, so this time, let's try the integral from 0 to pi over 2. So cosine of 2x over 3 dx. So let's try this definite integral here, right? Let's see if we can evaluate this one. So as you look at your integral, so we're going to convert the integrand from an integrand in terms of x to one in terms of u. And then we also have to convert the upper and lower bounds in terms of u also. So let's start off, let's let u equal the quantity inside of parentheses here. We'll let u equal, now 2x over 3 is actually 2/3 times x. I'm going to write it like this. So when you take your derivative, this will be du equals, now the derivative of 2/3 x is just 2/3. This will be 2/3 times dx on the right hand side. So the derivative of u is du, the derivative of 2/3 x is just 2/3. So maybe you drop that variable when you take the derivative on the right hand side. Now we're going to solve this for dx. So to get the dx by itself, I'm going to multiply by 3 over 2. Let's multiply this side by 3 over 2 also. So now we've got 3 has du equals dx. All right. Now we're ready to convert the integrand from an integrand in terms of x to one in terms of u now. Okay, so let's see, what would our integral? So well, let's go ahead and do the upper and lower bounds also. So we're going to do those two. All right, so we'll do the upper bound first here. Let's let u equal. So that's u of pi over 2 would be equal to, let's see, 2 times pi over 2 over 3. So let's substitute that in for x. Now as you multiply 2 times pi over 2, the 2's will cancel out. And that'll simplify then as pi over 3. So as we set up our new integral now, this will be, our upper bound now will be pi over 3. Okay, let's do the lower bound. Okay, this will be u of 0, okay, which would be 2 times 0 over 3 or just 0. So the lower bound is still 0 now. Okay, the lower bound is still 0, and this will be cosine, okay, u times, now dx, let's replace the dx with 3 over 2 du. So this will be 3 over 2 du. Okay. And I think this here I can erase now. Right. Now let's pull that 2/3 out in front of our integral now. This will be 3 over 2 integral 0 to pi over 3 cosine u du. Okay. All right. And that wasn't too bad. We've rewritten the entire integral now from an integral in terms of x to one in terms of u. So the integrand is going to just be cosine u times 3 has. The upper bound is pi over 3 and the lower bound is 0. Okay. And see, now we're ready to evaluate. Let's find our antiderivative here. Now the antiderivative of cosine is sine. Right? So as we evaluate this, this will be sine u from 0 to pi over 3. Okay, so we got our antiderivative. Now it's just a matter of substituting the upper bound minus the lower bound. And we bring the 3 over 2 over also. So 3 has times sine u times pi over 3 to pi over to 0. All right, so now substituting the upper bound minus the lower bound, we'll have 3 has sine pi over 3 minus 3 has times sine 0. Now, if you want to, you can just pull that 3 has out front and then at the very end multiply by 3 has. And I'm not going to do that. I'm going to go ahead and multiply the 3 has as I substitute the upper and the lower bounds of both parts. But you can pull it out front kind of and then multiply by 3 has at the end of your problem. So that will work too. Okay, first of all, sine pi over 3. Now if you remember your unit circle, so remember your unit circle, pi over 3 would be about right here. Okay, that's going to be 1/2 square root of 3 over 2. The x value is cosine, the y value is sine. So sine pi over 3 is actually square root of 3 over 2. So it'll be 3 over 2 times the square root of 3 over 2 minus. Now sine 0 is 0, so it'll be 3 has times 0. So keep my brackets here. Now as you multiply, this will be 3 times the square root of 3 over 4. Minus 0, so that's going to be our answer here. So it'll be 3 times the square root of 3 over 4. The square root of 3 over 4. Now the decimal on this, I got the decimal, I did that earlier, is 1.2299. So approximately 1.299. So maybe with a decimal answer, this would be the decimal answer. Okay. Okay, now let's see, we've done a trig problem. Let's try a radical example now. So let's try some radical. Okay, so this will be problem number 3. All right, so we'll try 1 or 2 radical problems. So let me erase this one. All right. Erase this. There we go. All right. Now, problem number 3. Okay, let's see if we can evaluate this radical here. So this would be the integral from 1 to 5. So from 1 to 5, x over the square root of 2x minus 1. So the square root of 2x minus 1 dx. All right, so this is our definite integral. Now to convert our integral from 1 in terms of x to 1 in terms of u. Let's see, now see the radical here. So this is equivalent to 2x minus 1 to the 1/2 power. So I'm just going to kind of erase this right here. Put this in parentheses to the 1/2 power. All right. And so let's see, what else could we do here now as we simplify this? This is equivalent to the integral from 1 to 5 x times 2x minus 1 to the negative 1/2 power dx. So I'm going to write it like this so I can see that negative exponent there. Now, to start off, let's convert our integrand to from 1 in terms of x to 1 in terms of u. Let's let u equal the 2x minus 1. All right, so this is what's underneath our radicals, we're integrating. So let's take the derivative of the left-hand side and the right-hand side. Now the derivative of u with respect to u will be du. The derivative of 2x is 2, and the derivative of 1 is 0. So on the right-hand side, the derivative of 2x minus 1 is 2 dx. Now make sure you leave that dx in there because you're going to solve for dx in just a minute. Let's divide this side by 2. Let's divide this side by 2. We have 1/2 du equals dx. Okay. All right, now let's see. Let's take the upper and lower bounds. Let's see if we can rewrite those now. This would be, let's take the 5 first. So u of 5 would be 2 times 5 minus 1, or 9. And let's try the 1. So u of 1 would be 2 times 1 minus 1, which is 1. Right. So the upper and lower bounds are going to be 9 and 1. So as we set up our integral now, okay, this will be the integral from 1 to 9, okay, x times u to the negative 1/2 power times 1/2 du. All right. Okay, now we got a problem. So we want it now. Once we got our substitution, we got the upper and lower bounds changed. Okay, our integral. There's nothing within our integrand here after we convert it in terms of u that will cancel out with this x here. So we're basically stuck with an extra x variable. Now to evaluate an integral, whether it's a definite integral or an indefinite integral, okay, you're going to have to convert the entire integral now from 1 in terms of x to 1 in terms of u. So every x variable has to be replaced. And here goes the bell. So every x variable is going to have to be replaced. Now I did one like this on my last video. So on this video I'm going to do 1 or 2. I'm going to do this one and the next one where what happens if you end up with an extra x variable that you can't get rid of. Now, so what you're going to have to do, if you remember this from my last video, you got to go back to the original substitution up here. Okay, let's bring this down here. All right, this is u equals 2x minus 1. Now, if this don't always work, it may be possible we can't evaluate this definite integral using U-substitution, but I believe in this case it will. If you look at this relationship, it's a little linear relationship. Let's solve our original substitution. Okay, let's solve this for x in terms of u now. So this becomes u plus 1 equals 2x divided by 2. So we have u plus 1 divided by 2 equals x now. So we can remove that extra x variable using u plus 1 divided by 2 now. So using from the original substitution, sometimes this will work. In this case, it does. All right, so our integral becomes 1 from 1 to 9. Let's see, x will be u plus 1 over 2. Okay, times u to the negative 1/2 power times 1/2 du. Okay. Hopefully you can see what we did. So we replaced the x here, okay, with the u plus 1 over 2. So that's equal to x, so we can make that substitution. Okay, and see, now we've converted our entire integral from an integral in terms of u, or in terms of x, to one in terms of u now. I think we can simplify this a little bit. I see a couple of fractions in here. Let's see if we can pull those fractions out. And let's see, as we substitute in then, let's bring the fractions out. We have 1/2 and 1/2. As you pull those out in front of your integral, it will be 1/4, 1 to 9. This will be u plus 1 now, times u to the negative 1/2 du. Okay, now, we're still going to have to simplify this. So really what it looks like with this problem here, the hardest part is going to be rewriting and simplifying our integrand here. Right. Now, before we can find our antiderivative, we're going to have to simplify this. That means removing our parentheses. And that means we have to take the u to the negative 1/2 and multiply inside our parentheses to the u and the 1. Now, remember now, when you multiply factors that have the same base, you're going to add your exponents. So this is u to the first power times u to the negative 1/2 power. This gives us 1/2 integral from 1 to 9. 1 plus negative 1/2 would be u to the 1/2 power plus u to the negative 1/2 times 1 is simply u to the negative 1/2. And let's see, we're going to have to erase some of this right here. I don't think we need this anymore. Okay, du. Right. Okay, finally, now we're ready to find our antiderivative and then substitute in to get our final answer. So we're going to substitute our upper bound and our lower bound in. So let's go and get our antiderivative. The antiderivative of u to the 1/2. Remember, you're going to add 1 to your exponent divided by the exponent plus 1. So this becomes 1/4 times u to the 3/2 power divided by 3/2 plus, once again, add 1 to your exponent divided by the exponent plus 1 gives us u to the 1/2 power divided by 1/2 from 1 to 9. All right, so from 1 to 9. Okay, now let's see if we can simplify this a little bit. Then we'll be ready to substitute our upper bound and our lower bound in. So as we simplify here some, let's see now, 1/4, we have to invert this fraction and then multiply it. So this becomes 1/4 times 2/3. That'll reduce to 1, this will reduce to 2. So this becomes 1/6 u to the 3/2 power. Okay, plus. Now here we've got, let's see, this would be 1/4. This would be times 1/4 here also. So it'll be 1/4 times this. So we got our antiderivative. So it'll be 1/4 times that, 1/4 times this. Okay. And so as we multiply, it'll be 1/4 times, invert the fraction, it'll be 2 over 1. That reduces to 1, this will reduce to 2. And that'll give us 1/2. So this will be 1/2 u to the 1/2 power from 1 to 9. Okay. Finally, now we've got our antiderivative. We've got that all simplified now pretty much. Now it should just be a matter of substituting the upper bound and the lower bound in. And let's see what we get. Now let's substitute the 9 in first. Run out of room. I want to write a little bit smaller here, looks like. Substituting the 9 in will give us 1/6 times 9 to the 3/2 power, okay, plus 1/2 times 9 to the 1/2 power, minus, and let's substitute the lower bound in for u now. So that becomes 1/6 times 1 to the 3/2 power plus 1/2 times 1 to the 1/2 power. And let's see what we get. Now, let's start off this here. 9 to the 3/2 power. Now, first of all, 9 to the 1/2 power would be 3. So 1/2 would be a square root, so square root of 9 would be 3. 3 to the 3rd power would be 27, so it would be 27 over 6. Okay, plus, now the square root of 9 would be 3. 3 times 1/2 would make that 3 over 2. Okay, minus, this would be 1 to the 3/2 power is 1, so this becomes 1/6 plus 1/2. All right. And let's see, as we evaluate this, now let's see, 27 over 6, let's distribute this negative here now. So make that a negative 1/6, and a negative 1/2, and we'll change that to plus now. Now you gotta watch that minus sign there. Now remember, now you wanna make sure you keep these grouping symbols. When you substitute the upper bound, put that in brackets minus, then the other substitution, that's substituting the lower bound in. So if you don't keep those grouping symbols there, you're gonna knock off your sign, and that'll give you an incorrect answer at the end. So be careful. That's a negative 1/6 and a negative 1/2. So as we combine these now, let's see, 27 over 6 and a negative 1/6 would be 26 over 6. And let's see, 3/2 and negative 1/2 would be 2 over 2 or 1. So it would be 26 plus 1, which is 26 over 6 plus 6 over 6, and that'll simplify as 32. So 32 over 6. So that'll simplify to 32 over 6, or about 5.333. So as a decimal, so it'll be 32 over 6. And then the 32 over 6, I didn't reduce that, but that'll reduce to 16. And this will reduce to 16 over 3. So 16 over 3. So we'll reduce it all the way. Okay, so that's our third example. So we've done a trig example, we've done a radical example in which we ended up with an extra x variable. So remember now, if you got that extra x, nothing will cancel out with it. You go back to the original substitution and solve that for x, and that'll allow you to remove this extra x variable from your interval. Okay, let's try one more example here. So one more. This will be our last one. Now this last problem is we're going to be stuck with, I'll warn you now, we're going to be stuck with an extra x variable again. So those types of problems tend to get students a lot of trouble. So in this video, I'm going to do two problems. The one we just did, and the next one, where we're stuck with an extra x variable. All right, and so let's see how we want to do the next one here. Let's see if I can get this erased now. These are long problems, and they just take quite a bit of space. All right. Okay. Now, so save a little bit of time. I may skip some of the arithmetic on this one. I'll let you guys do the arithmetic. But now, on this next problem, this will be problem number 4. That's problem number 4. Move this out of the way. Right. Now, problem number 4. Now, this time, let me pull this up. First, let me move my blue Maxwell House coffee can out of the way. So you can see it here. It's kind of scoot this out of the way. And let me set this one up. This is a little bit different. Now, this problem, I'm going to do this one as an area problem. Now, it says we're going to find the area of the shaded region. Now, you can see our function is y equals x squared times the cube root of the quantity x plus 2. This is what the graph looks like. Now we're going to find the area of the shaded region. You know, most textbooks will have this type of problem in them, where you have to set your own definite integral up to describe the area between the curve and the x-axis. Right, so that's what we're looking at here. So if you look at this area, we're talking about the area between the curve and the x-axis from -2 to 6. So as I set my integral up, okay, we're going to be integrating from -2 to 6. Right, and our function is y equals x squared times the cube root of x plus 2. Right, so that's going to be my integrand. This will be x squared times. Now the radical, we're going to change that to be x plus 2 to the 1/3 power dx. So this is our definite integral. This is the one we're going to set up. So like I said, most textbooks that have this type of area problem in them, where you'll have to calculate the area between the curve and the x-axis, and you have to set your own definite integral up to do that. So I'm going to set it up. So we're integrating from -2 to 6, x squared times the quantity x plus 2 to the 1/3 power. Okay. Now, as we set this up, now let's see, now in just a moment, I'm going to take the problem down. So if you need to copy the problem down for your notes or whatever, you need to go ahead and do so, because I'll be taking this down in just a second. But let's go ahead and start our U-substitution. We'll let U equal x plus 2. So let's let U equal x plus 2. And let's move this out of the way. Right, so u equals x plus 2. Take the derivative of both sides, so the derivative of u is du. The derivative of x is 1, so it'll be 1 dx or just dx. So du equals dx. That'll be a direct substitution there. Okay, now let's do the upper and lower bounds now on our definite integral. So let's do the upper bound first. So u of 6 would be 6 plus 2, which is 8. And the lower bound now, u of negative 2, becomes negative 2 plus 2, which is 0. Right, so the new upper bound will be 8. The new lower bound will be 0. Right, so when you substitute 0 in for x. Right, so in terms of u, would be 8 and 0. All right, so let's make our substitution now. So the new integral becomes from 0 to 8. That's from 0 to 8 times x squared. So instead of x plus 2 to the 1/3, this will be u to the 1/3 power times du. All right, now I kind of warned you at the beginning of the problem. I said we're going to get stuck with an extra x. So once we've converted, so you look at our integrand here, there's nothing within the integral that will cancel out with this x squared. So you're kind of stuck with that x squared. And remember, I said anytime you end up with this type of situation, so you're going to have to go back to the original substitution. All right, so the original substitution, let's bring the u equals x plus 2 down. And that means that u minus 2 is equal to x. So if u equals x plus 2, then u minus 2 is equal to x. So we're going to get rid of the x by substituting u minus 2 in for x. All right. And let's see, so we set this up then. I'm going to need a little room here, so I want to erase this. So once again, we got the u minus 2. So we set up our integral now. And this will go from 0 to 8 now, so 0 to 8. Instead of x squared, now this becomes a u minus 2 quantity squared. So u minus 2 quantity squared times u to the 1/3 times du. All right. Now, as you look at our integral, all in terms of u, this is what it looks like now. So let me see if I can take this from here down, put it out of the way. Okay. Now, in order to find our antiderivative, we're going to have to simplify our integrand here. So you got u minus 2, a binomial squared, then times u to the 1/3 power. So let's see how this will simplify. First of all, the u minus 2 squared. So u minus 2 to the 2nd power. Now I'm going to use a shortcut here to simplify this and expand it. Now if you need to, you can use the full method, so you could fold it if you want to. I'm going to use the shortcut. Now the shortcut, you take the first term of your binomial and square it, so you get u squared. Then you multiply the two terms together and double it. So u times 2 is 4, so it becomes minus 4u. And then you plus the square of the second term, so plus 4. So when you expand the u minus 2 squared, it expands as u squared minus 4u plus 4. This becomes the integral from 0 to 8. So u squared minus 4u plus 4 times u to the 1/3 power du. Okay. Let me erase this. All right, now, before we can find our antiderivative, I said we need to finish simplifying our integrand here. So let's take use our distributive property now. We can, if we have simplified our power there, we can multiply the u to the 1/3 inside our parentheses. And as you multiply, remember factors with the same base, you have to add your exponents. So when you multiply u to the 1/3 times the u squared becomes, this goes from 0 to 8. Let's see if I can squeeze that in at the end of my board here. This becomes, and you got to add the 2 and the 1/3. So 2 plus 1/3 would be, let's see, would become what, 6 over 3 plus 1/3 or 7/3. So now this becomes u to the 7/3 power minus 4 times. As you multiply u to the first power times u to the 1/3 now, that gives us 1 plus 1/3 or 3/3 plus 1/3 or 4/3. This becomes now u to the 4/3 power. So 4 times u to the 4/3 power, and then 4 times u to the 1/3 power is just plus 4 u to the 1/3. All of this du. Okay. All right, now let's see, I believe we pretty much have this simplified now. We've got our integrand pretty much simplified, all in terms of u. Let me just double check my notes here, make sure that we're right. Okay, so I believe we're ready to go. All right, so we're ready to find our antiderivative, and then we'll go ahead and start substituting in to evaluate our definite integral. Okay, now you got three terms here. You're going to find the antiderivative of each term. Let's start off with u to the 7/3 power. Now we're going to find your antiderivative. You're going to add 1 to your exponent, divided by 7/3 plus 1. So now remember 7/3 plus 1 is the same thing as 7/3 plus 3/3, or 10/3. So when you find the antiderivative of u to the 7/3, it becomes u to the 10/3 power divided by 10/3. Okay, minus 4 times. So I better use brackets here. I'm going to use parentheses again. So times 4. Now when you multiply, so when you find the antiderivative of u to the 4/3, we're going to have to add 1 to your exponent. So 4/3 plus 1 is 4/3 plus 3/3, or 7/3. All right, so as you find the antiderivative of u to the 4/3, it becomes 4 times u to the 7/3 power divided by 7/3 plus. Okay, let's do the last one down here. Erase this. Okay, finding the antiderivative of u to the 1/3. Now we got 4 times. Now 1/3 plus 1 is 1/3 plus 3/3, or 4/3. So finding the antiderivative now of u to the 1/3 becomes u to the 4/3 power divided by 4/3. All right, all that from 0 to 8. Okay. All right, let's see if we can simplify this just a little bit now. So let's see if we can simplify some. Now, let's invert and multiply each of these fractions here as we simplify here. Invert the 10/3 becomes 3/10 u to the 10/3 minus. Now, when you invert and multiply 7/3 and 4, you have 4 times 3/7, which make that 12/7. So now this becomes minus 12/7 u to the 7/3 power. Okay, plus. Now 4/3. Now invert the 3/4, so it becomes 4 times 3/4. That's 4. 4s will cancel out, and that gives us just 3. It'll be plus 3. From 0 to 8. Okay. That'll be plus 3u to that. So we get that rest of this in here. So that'll be that the 4s will cancel out, gives us 3u to the 4/3. So u to the 4/3 power from 0 to 8. All right. Okay, now we found our antiderivative, and now we want to substitute the upper bound and the lower bound in. So as we evaluate this, now substituting the upper bound in first becomes, let's see, 3/10 times 8 to the 10/3 power. Okay, minus 12/7 times 8 to the 7/3 power, plus 3 times 8 to the 4/3 power, minus. Now, substituting 0 in for u gives us 0. Okay, so let's make that a little bit easier. So substituting 0 in for u, that'll all become 0. So as we evaluate this now, okay, this becomes, like I said, I'm going to skip some of the steps here with the arithmetic. Let's see, now 8 to the 10/3 power. Now 8 to the 10th power, the cube root of 8 is 2, so that's actually 2 to the 10th power times 3. All right, so 2 to the 10th power is 1,024. So this becomes 3/10 times 1,024 minus 12/7 times. Now, when you do 8 to the 7/3 power, the cube root of 8 is 2, and it becomes 2 to the 7th power. Okay, which becomes, so 2 to the 7th power is 128. So 128 plus, now, let's see, now the cube root of 8 again is 2, so 2 to the 4th power would be 16. So this becomes 3 times 16. All right, so we evaluate our arithmetic here. So let me erase this. And let's see, now the 10 and the 10,024 will simplify. That will reduce to 5. This will reduce to 512. 512 times 3 is 1536. This becomes 1536 over 5 minus 128 times 17 is 1536. This becomes 1536 over 7 plus 3 times 16 is 48. So it becomes 48 over 1. All right. Now, combining each of these gives us, I'm going to go ahead and skip over 7,452. I'm sorry, 4,752. 752 over 35. So you have at least come to the denominator of 35. And as a decimal, this would be 135.771. Okay, from what I can tell, I believe we got everything correct. So I did most of the arithmetic here to kind of show you how that goes. But like I said, once again, I want to make sure that we did another example here where when you convert everything in terms of u and your integrand, you're stuck with that extra x variable now, right? In this case, we were stuck with the x squared. There's nothing that will cancel out with it when you do your substitution. And remember, you got to go back to the original u substitution, and then by rearranging that, typically you can substitute it in for x, and then remove it. But this is just we've done 4 examples now of u substitution and evaluating a definite integral using u substitution. So hopefully you found these 4 examples helpful. So now we're ready to do our homework.